Welcome to VLearn. This is session number 5 of DBMS on relational algebra. In this session, we are going to cover introduction of relational algebra, fundamental operations, select, project, union, set difference, Cartesian product, rename, set intersection, natural join, and division. Now, before to tell about something the query relational algebra, I would like to tell you about the query language. Query language is a language which user requests information from the database to extract the data. It is further categorized in two parts. One is procedural or non-procedural. In the procedural language, the user instructs the system to do a sequence of operation on the database or to compute the desired result. And in non-procedural language, the user describe the desired information without giving the sequence procedure for obtaining that information. So the here relational algebra is a procedural language, procedural query language. It consists of a set of operations that take one or two relation as an input and produce a new relation as a output. Now we will apply these queries to extract the data from the table. We use here select, project, union, set difference, Cartesian product, rename, and there are some other operations are the set intersection, natural join, division. One thing here are the select and project operations are unary operation because they are operate on a single relation. And here the union, set difference, Cartesian product, rename operation are the binary operation. Because they operate on the pairs of the relation, not a single. Now, how we apply the select operation? In the select, we take out the particular number of rows that we want to extract from the data. It select the particular numbers of rows by according the condition. Here the single row are also called tuples. Tuples are more than one row and tuple is on the single row. To identify a set of tuples which is a part of relation and to extract only those tuples out. The select operation select tuples. Here select operation take out the particular rows which satisfy by the given predicate or the condition as given by the user. It is a unary operation that I already told you that the select operation is unary because we apply on the single relation. This select operation is represented by this symbol is known as sigma. Now let's consider an example of this is a table. In this table we use three attribute also known as the here column. I take here three column. One is the on the book I take this is a table for a book. Here the one column is account number, year of publish and title of a book. So this table contains the three columns. Now we apply the query select on this table. Now this is the previous one, the book table, and here want to example to select the relation book, all the books whose year of publication is 1992. In this example, in this table, I already give her some information related account number, year of publish and title. Now in this example, I want to extract those books are published in year 1992. इस क्वेरीज को एग्जीक्यूट करने के लिए हम यूज़ करते हैं द select statement. Here as writing the select we use here symbol the sigma. Sigma is as used for select. What it select? Year published is equal to 1992 and in the circle bracket we write the table name. Then it will show you those rows which are published in the year of 1992. This is the just theoretical representation of the sigma. We can use it in the practical. I will show you in the next session by using how to can extract and select the data with the help of this query. In the query we use instead of this symbol we use the word select. Consider one more example. Let's select in the relation book all the books whose account number is greater than or equal to 56782. Now we verify here account number. Here the first in the table I use a column is here account number. Now according to this I use here symbol, this sigma means select account number, those are greater than and equal to this number, and in the circle bracket we write here the table name. This was the example of select operation. Now the next operation we will apply the project operation. In the select operation we take out the particular numbers of rows as required by the user, but in project operation we take out the particular numbers of columns of the table, which is also called attribute. The project operation return its argument relation with certain attribute left out. It is unary operation defined on the single relation. It is denoted as the symbol pi. The select symbol was operated by sigma and this is denoted by the symbol is pi. Now consider an example. They list all the title and account number of the book relation. As I show you the previous एक टेबल आपको शो की थी, इस टेबल में हमारे पास कॉलम थे अकाउंट नंबर, पब्लिश, ईयर ऑफ पब्लिश एंड टाइटल. अब मैं सिर्फ वो कॉलम्स निकालना चाहती हूँ, इस टेबल में से एक्सट्रैक्ट करना चाहती हूँ सिर्फ अकाउंट नंबर एंड टाइटल, नॉट पब्लिश. इसके अंदर हम पब्लिश टेबल कॉलम नहीं देखना चाहते, सिर्फ मैं अकाउंट नंबर एंड टाइटल कॉलम देखना चाहते हैं. तो इसके लिए हम क्वेरी एग्जीक्यूट करेंगे पाई हेयर टू सेलेक्ट पर्टिकुलर अकाउंट नंबर, title, and in the bracket we write here book. So it will extract the column, these two columns from the table book. After that we use the union operation. As to what do the union operation? It used when we need to some attribute that appear in either or both two relations. It is denoted by the symbol like this in the U shape, that is the union. Here the consider example to how union work. There I take the three table. One is the borrower, depositor and customer. In the borrower table they are taken the two column. One is the customer name and loan number. Second depositor table consists the two column. One is customer name and account number. Third table customer contain three column is customer name, street number, customer city. Now want to execute a query, list all customer who have either an account or an loan or both. अब इस यूनियन ऑपरेटर के थ्रू हमारे पास कुछ कंडीशंस होती हैं जिसके थ्रू डाटा को एक्सट्रैक्ट करता है. दिस कंडीशन इज दैट here R and S are table on which union is applied. For a union operation to be valid, two condition must hold. First, the relation and the must be of the same arity, that is, they must have same number of attribute. And second, domain of ith attribute of R and the ith attribute must be same of all. Like the data type we are using here must be same and the attribute should be same to extract those data from the table. Here example we are taking list all the customer who have either or account or loan or both. इस यूनियन के ऑपरेशन से दोनों में जहाँ पे लोन होगा दोनों कॉलम नंबर वेरीफाई होंगे तभी वो डाटा को एक्सट्रैक्ट करेगा. एग्जाम्पल आई यूज हेयर पाई मीन्स सेलेक्ट कॉलम व्हाट कस्टमर नेम. हेयर एट द लिस्ट ऑल कस्टमर मीन्स इट विल एक्सट्रैक्ट द कॉलम ऑफ कस्टमर नेम फ्रॉम द टेबल बोरोवर एंड अप्लाई यूनियन ऑपरेटर हेयर अगेन टू द पाई ऑपरेशन and on the customer name from the table depositor. Now it match the attribute and extract that condition according to the satisfy the condition and take out the loan and account from the both table. Now the set difference operation. Set difference operation is find the tuple in one relation but not in another. Like some data I want to in table A but not exist in B, then it extract only those data. Example, find the name of all customer who have an account number but not a loan. For difference operation we use the symbol minus. Like here the pi again operator apply to take out the particular column of customer name from table depositor. There in the bracket is depositor table. Here use the minus कॉलम कस्टमर नेम फ्रॉम द बोरोर। तो इस क्वेरीज में क्या होगा, जो हमने कहा था नेम वो एक्सट्रैक्ट करें दैट हैव अकाउंट बट नॉट अ लोन, तो इट विल रिड्यूस दैट विच विल नॉट एग्जिस्ट इन द बोरोर। नाउ द Cartesian product operation. Cartesian product operation allow combining information from two relation. It is denoted by the symbol this cross. Here R and S are the two relation, where R and S are the relation. Like this one table shown in front of you is the R. Here consider two column A and B, and consider the next table S, and here the two column B and C contain this data. Now we apply on this two table Cartesian product relation. कार्टेशियन प्रोडक्ट में क्या होता है, हमारे इन दो टेबल्स के थ्रू आर एस के थ्रू जितने नंबर पॉसिबल कॉम्बिनेशन फॉर्म होते हैं, इट शो द और कॉम्बिनेशन हेयर। लाइक दिस इज द रिजल्ट आर कार्टेशियन प्रोडक्ट ऑफ एस क्रॉस एस गिव यू दिस रिलेशन ऑफ दिस टू टेबल। आई यूज हेयर इन द आर टेबल ए कॉलम कंटेन ए बी ए and correspondingly B data 1 to 2, and the next S table contain B column which is there 3 and 2. Now it make the possible relation from here A will combine all combination of the table this B1 3 and 2. So result will give here A from table R, from B it take 3, and again A from the table B it take 2. So it show the first possible combination of take single A, it combine next two operation from the table S. The result will generate all. First it take A, B and the combination form here by the relation S dot B and S dot C. Similarly, if I take here B row, it again combine with the next table relation 3 and 2 and give you the result B with their 3 and as well as B with the 2, and the last one here I take again A with the B value 2, I take here again A with the B value 2 combine with the S relation as 3 and S relation as well as 2. So it combine the relation from total number of possible combination from both the relation and show the result. This was the Cartesian product relation. Now the Cartesian product operation here, the what is the relation has n1 tuple and relation has n2 tuples. There is possible R cross S as n1 into n2 show the all total number of possible tuples as I already told you. Now one example to borrow and the customer name loan and loan number, branch name, city and amount. Now we want to take here list all name of all customer who have loan in Parish branch. For what we query apply here, like this one is the query for Cartesian product. It will extract the customer name. Here the select condition apply because we want here all those customer who have loan in the Parish branch. Now for the Parish branch what we apply? We apply here sub condition. First it match the loan are equal, and after that it match the branch name is equal to Parish. Now here in the circle bracket this show here borrower cross loan means here Cartesian product applied. Through this query we extract the data as well as condition by the Cartesian product. Now next is the rename operation. The rename operation is denoted by this symbol by which we can rename the relation. Here E is denoted the relational algebra expression. Now we apply here rename like this symbol with the cross E on the relation that return the result of expression E under the name cross. Now how can I apply this symbol? We are using the cross symbol, and in this one given the all name A1 to up to AN, and finally it return the result of expression E as we mentioned in the circle bracket. This that is the renamed. Now द सेट इंटरसेक्शन ऑपरेशन, जैसे कि आप सब जानते हैं मैथमेटिकल के अंदर हम इंटरसेक्शन ऑपरेशन भी यूज़ करते हैं। उसके क्या होता है, जो भी हमारी कॉमन वैल्यू होती है दोनों टेबल्स के अंदर वो डाटा एक्सट्रैक्ट करके देता है। सेम हेयर दिस इंटरसेक्शन अप्लाई the all the common data it will extract which exist in the both table. Like here we take an example, Again, same the borrowed table where the column customer name and loan number. Second is depositor where the customer name, account number, and third is customer with the customer name column, street number, and customer city. These are the column in the customer table. Now we want to list all the customer who have both a loan and a account. Now in this query, in this intersection, it take out those data which must exist in both table. Example, this is the query. How we extract the last example. We use here, first symbol is the project that will extract the column of customer name, and the circle bracket is the show the table name from the borrower. Intersection is apply to extract the customer name from depositor. Means what to do this query? Those name will extract which are the same as well as borrower and the depositor. Now after that there is the natural join operation. Natural join operation is basically a binary operation because there is require more than one relation as a combination of Cartesian selection also the Cartesian product into the one operation. So it is denoted by this symbol of the natural join operation, and it is also associative because it see the value of Cartesian product that should be matchable, then according to it extract the data. Now about the natural join operation, it form a Cartesian product of two argument, then perform a select forcing equality on those attribute whose appear in both the relation. As I already told you, आपको जैसे ही बताया कि हमारे वो एक्सट्रैक्ट डाटा निकालेगा जो दोनों के दोनों आर्गुमेंट होने जरूरी हैं दोनों टेबल में, तभी वो डाटा एक्सट्रैक्ट करके देगा. एंड फाइनली रिमूव डुप्लीकेटेड एट्रीब्यूट. Here R and S are the two relation with attribute with denoted by capital R and capital S. If I use here symbol like R intersection S is equal to 5, means there is no attribute is common, then is this result representation is like this. R, there is this symbol is the natural join of S relation is equal to R. This is the Cartesian product symbol with the S. Example is of here the natural join was taken this example of R relation. Here this column in the A, B and C, and as well as the S table there is the column this B and D. Now this is the Cartesian join representation of the both table of R and S. It joined the table by saying the same column is here is in S table is B column. B column is here. Now how to it join those table? It see the common is same in both is what? B and E. In the C, in the table R में आप देखेंगे इस B column में आपके पास B, E, H three values are here, and in table S here in the B column value are B, P and E. Now you see B and E are also in this table and B, E are also in this table. Now it combine the both table on this operation. The result we get like this, see in this table column B contain only those values which are same in those table B and E, and join the all remaining attribute in this table. So what it says again, if R, A, B, C and B, D, and then code representation is like this. We extract data is can be represented by this query. R as the Cartesian product of S relation, and here pi with the selection of column of R dot A, R dot B, R dot C and S dot D. This is the select symbol on matching the table from R from relation B attribute and S from B are equal, then it combine the all possible number of combination. Now the division and quotient operation. Division operation also can be applied here. It is denoted by the symbol this division. Let's consider here R and S be a relation. R division S is used here. The result consists the restriction of tuples in two attributes means unique of R. It will match the unique value, and example that is the header of it are not but not in the header of S, for which it hold that all their combination with tuple in S are present in R. Suppose we consider example. In this example you will see consider a R table are relation in which A and B are the column. A column contains this value A, B, A, P, P, and the B column contains this value 1, 2, 2, 3, 4. And one more relation here is S, which contains the column B. It contains value 2 and 3. Now if I apply here division operation, so it gives the result this. How we get this result? Let's see. In this division operation, when we apply, we see here the B value. B is dividing by the relation R and the B contain 2 and 3. Now it see in the table R, we get value 2 and 3 where? 1 on the B, first B, second 2 are on second A, third 3 on P. So it extract on these 3 value from the table. You will see the relation we get from the A are the B, A and P. That's all from this session. Now this is the exercise you can try. What is the relation algebra and what set operation we can apply. Thank you.